What are we learning? Okay.
Parallelogram.
We're proving how to make a quadrilateral parallelogram. Okay. If you notice these theorems, and actually this is the definition, right? So this is how you would abbreviate opposite sides are parallel, implies that you have a parallelogram. These are the converses of the ones that we just did. Okay, so remember like when we would talk about proving like alternate interior angles are congruent, you'd have to have parallel lines, right?
Yeah.
What if you have alternate interior angles congruent? That proves the lines are parallel. That's the converse. So this is the same idea, but with parallelograms. No, there's only one new one.
I have one. Yeah, the one pair of sides.
Yeah, these are all converses.
That last one.
So these are all converses of 6.2 theorems. This one is a new one. Okay. So if you have opposite sides are congruent, we have a parallelogram. If you have opposite angles are congruent, we have a parallelogram. If diagonals bisect each other, we have a parallelogram. This is the only new one. If you have one pair of sides, so what this one looks like. So let's say these pair of sides are parallel, and if they're also congruent, that proves that it's a parallelogram. Okay. But they have to be parallel and congruent. It has to be the same pair of sides.
So the second one, the opposite sides are
Congruent.
Oh yeah, never.
Right.
What if it's a trapezoid?
Well, a trapezoid, here's the thing about a trapezoid. This is what makes a trapezoid different. You have one pair of parallel sides, but these two sides are not parallel to each other. They could be congruent. This would be, which we're going to learn towards the end of the chapter, this would be an isosceles trapezoid. But a trapezoid is not a parallelogram. Do you see the difference?
Is there a sign for parallelogram?
Sure.
Yeah, it's like a little square.
What's wrong with that? I thought that was a parallelogram.
No. Just parallelogram. Okay. All right, so here we want to prove that theorem. Okay. Now, the only way that we can assume that we have a parallelogram at this point is the definition. So if we can get opposite sides to be parallel, then by the definition, we know we have a parallelogram. So that's going to be our goal in this proof. We want to try to get the opposite sides to be parallel.
Well, I'm very confused. It says that if they're congruent in the parallelogram.
Okay. Remember, when we're proving a theorem, we cannot use that theorem.
Oh,
And
I
every
did not
single
know.
proof would be a two-step proof.
Why can't
That'd be pretty neat.
Really wouldn't get us where we need to go, but sure. Okay, AB is congruent to CD, and we have AD is congruent to BC. So these two are congruent. So that's all we know. We want to try to get to opposite sides.
Draw a line. You draw a line.
Okay, we can draw a line. So remember, we can
About
make two triangles. Let's see. If I draw one of the diagonals.
You can do the angles.
Okay, well, hold on. First of all, remember when we were doing a lot of the proofs, we were proving triangles congruent
What if you
first.
do opposite? Or you could just do
Well, hold on. We don't know that it's a parallelogram.
like
Okay,
From there,
but what do we notice if I draw one of the diagonals? That can be a side that they share.
Yeah.
All right, so I'm going to put DB. Guys, shh. Congruent to DB. That's our reflexive property. Okay, now, can I prove the two triangles are congruent?
Yes.
Yes, so I'm going to prove them congruent by side, side, side. Now, we have to make sure that we get the order of the letters. Doesn't matter how you name the first triangle, it depends how you name the second one. So,
ADB.
so ADB, CBD.
Wait, do you have to do a theorem for cutting parallel to them?
Nah, you don't need that. Okay,
But I'm confused why you couldn't just in the beginning do opposite side of
Because we're proving.
because we're proving the theorem.
That's what I asked you.
It's one of those, once we prove it, then we can go to the shortcut.
Sometimes part of these things do with those.
All right. I want to say angle ABD is congruent to angle BDC. And I also want to say these two are congruent. So angle ADB and angle DBC. Okay.
Just make all the angles congruent.
Okay, hold on. There's a reason I chose those two pair of angles. Now, the reason they are congruent comes right after side, side, side. So what's the reason? CPCTC. Okay, we're going to be using, they are alternate interior angles, right? And what happens when alternate interior angles are congruent? What's that tell us about the lines? They have to be parallel. So I can actually say AB is parallel to DC, and I can say AD is parallel to BC. We need a reason. Converse of alternate interior angles. Yes.
Step 4, not the alternate interior angles theorem.
Okay, they're congruent because of CPC. I can't say alternate interior angles theorem here because I would need to have the lines parallel, but that's our whole objective here. We're trying to get the opposite sides to be parallel so that we can prove that it's a parallelogram.
Oh.
You know what I mean? So I'm basically done now. I can prove ABCD is a parallelogram, and this is just definition of a parallelogram because what's the definition? Opposite sides are parallel. Did I not prove that the opposite sides are parallel? I did, right? So now I can say it's a parallelogram based on that. Remember, a lot of these proving of the theorems, I don't have you necessarily doing those for homework, right? It's a process of working through what we have previously learned, right? Alternate interior angles, converse. How do you prove?
Excuse me, do you remember? I wasn't doing that.
Okay, take a look at the next page. Okay. This one, we're going to be proving which theorem? Opposite angles. So now I'm going with opposite angles are congruent. Can I prove that it's a parallelogram? Let's think about it. Evan, are you done? Okay.
We don't have a class to go over practice sets, right?
We don't usually have an extra review day before quizzes. It's the same in Algebra 2 honors. Or Algebra 2 for that
Is there
matter.
bonus tomorrow?
Thursday. We don't, we have it before bonus.
Are all of these all of these things over here? Are they all definitions of parallelogram?
Yeah,
You have lunch tomorrow?
I have a meeting during lunch.
This case, I'm finished. Sorry.
Okay. I'm here at my usual 8 o'clock.
Someone Ellen gets here.
Yes. You can't drive yet. So,
Is he gonna drive you to school?
Yeah.
When he's like a junior?
yes, it's permanent.
That's what I remember.
But my daughter will have her permit way before him, so.
Well, it doesn't she already?
End of this,
I could get my permit
End of
in
this
exactly a month.
okay, well,
Is she like,
you're older for your grade.
am I older than her?
I don't know. I would,
Because she's a sophomore.
yeah. There are sophomores that
Could I be a
are
sophomore?
15.
How would you could?
I like there are sophomores that are born in October.
So why do I have to?
Okay, that's a discussion for another time. Let's continue. Okay, I did purposely put in measure of angle A equal to measure of angle C because we are going to use measure. I know it's been a while since we've done this.
Oh, that's where it equals 180.
Okay, so measure of angle A equals measure of angle C. Measure of angle B equals measure of angle D.
Oh, the A plus B equals 180. No.
Okay, what do we know here?
A plus C has to equal B.
Okay. What do all four angles in a quadrilateral have to add up to? 360. So I'm going to say measure of angle A plus measure of angle B plus measure of angle C plus measure of angle D, running out of room, equals 360.
Definition of parallelogram?
That's just definition of interior, some of interior angles. Or actually, I think it's a theorem.
Oh my god.
It's okay.
So much.
You don't need to, we're only ever going to be using this one in class. You're not going to need to do this for homework.
Wait, or on the quiz,
Right.
So there will be no proofs on the quiz?
I didn't say that. I just said not one like this.
Oh,
Okay. All right. What do you think?
We're gonna have all the like.
Opposite angles are two right.
Okay.
Can't do-
Again, what are we trying to do? We're trying to get the lines to be parallel. So can I replace A with C or C with A?
Yeah. So then you get two variables instead of four.
Okay. So watch.
What's the point of that?
If we can get two consecutive interior angles to be supplementary, doesn't that make the lines parallel? So could I get B and C adding up to 180?
Yeah.
And that would make these two lines parallel?
Yeah.
And can I get A and B or D and C to add up to 180?
Yeah.
By using substitution, and then we'll use division.
So
Okay?
how do we make them?
So I'm gonna make two statements here. Which ones do we wanna get? We wanna get A and B, and then maybe B and C? Can we get that? So let's see. So I'm gonna leave this measure of angle A plus measure of angle B. I'm gonna replace the second, or the angle C with angle A. And I'm gonna replace D with B. Okay, so this is substitution. Right, I replace C with angle A and D with angle B. Can I do the same thing again, but get everything to be with angle B and angle C? What can I replace A with? C. I'm going to leave measure of angle B, measure of angle C. I'm going right back to, I'm using the same statement a second time, but replacing angle A and angle
How are you
D.
getting anywhere? I'm so confused.
Okay, let me finish writing it in and then I'll go back. Angle D is equal to angle B. So I'm going to put measure of angle B equals 360. I'm taking
Because it never
this
says angle A is equal to angle B.
A and B. No, A and B are not equal.
Oh, wait, you ever see angle C is equal to angle?
Right, so remember when I circled these? I wanted to take this statement and I wanted to replace everything so that it was just A and angles A and B. And then I want to get these two, because I need to get these two to make these lines parallel, and then I need to get these two to make these two lines parallel. So then I use the same one, and I replaced A with C, substituted that, left angle B, left angle C, and I replaced D with angle B. It'll all come together in a minute. So I have 2 measure of angle A plus 2 measure of angle B's.
Or wasn't it C that you used?
No, that's the second one. And I have 2 measure of angle B plus 2 measure of angle C's equal 360. This is just simplifying, so I'll just say substitution. I didn't change the value of anything. Almost done. What can I do next?
5 by 2.
Divide everything by 2. So I have measure of angle A plus measure of angle B equals 180. And I have measure of angle B. Looks like I could have left some more room here. We have two more steps, and that's it. Did we get 2 pairs of consecutive interior angles to be supplementary? We definitely did. So that tells us, what do we know about the lines? They have to be parallel. So I have AB has to be parallel to, did I print out the wrong one? BC and what? Or sorry, DC. And AD is parallel to BC. This is converse of consecutive interior angles theorem. Oh, barely enough space. Yeah, Ariana.
Why is DC? It hasn't been in any of the equations.
What do you mean?
Like, you haven't used the measure of angle D at all.
Oh, I didn't need it. I could have done D and C or A and D. You just need 2 pairs that are consecutive to make the lines parallel. I just chose A and B and C. That's not the only combination that I could have used.
How does all of that math lead to those lines being parallel?
Well, AB and DC have to be parallel because angles B and C add up to 180. And now we have ABCD is a parallelogram. Definition of parallelogram. Okay. Bit of writing there. Crazy. Don't worry. It gets easier from here.
You zoom in.
Oh, where? Here? Okay. All right. No, I'm not going to give you a proven of theorem, but you might have to apply the theorem.
Yeah.
Okay, determine whether each parallelogram or each quadrilateral is a parallelogram. Justify our answer. Okay, what do we need to check for? Well, opposite angles are congruent. We should also make sure,
They all add up.
do these also add up to 180?
Yeah.
Yeah, because just be careful that the numbers make sense. Right, because it still has to add up to 360 at the end. So this is yes.
So even if they're congruent,
Well, what if we gave you like, this is 70 and this is 70, and I said this was 100 and this is 100, like as a trick? Would that make any sense? That can't be a parallelogram,
that was
right?
not obvious, but like, would you
Yeah.
like give us like a really hard one where you make us check it every single time?
Well, I might give you one where I only give you 3 angles and you have to figure out the 4th.
Excuse me, what's the reason? If you give us 3, then the 4th's easier. You just go opposite, right?
Okay, so I can use, there's two choices I can have. But the one, or I would just go with the opposite angles. We'll use our
both
little
opposite angles are congruent, then it's a
parallelogram. Yep.
So why
Okay.
didn't we just do that before? In the past problem.
Because we were proving the theorem.
So
You're
we'll never
proving
do
that
that.
the opposite angles
We'll
are-
never do that again. Because now we have.
Because now we proved it. Now we can just jump
So it
right to
never
the
has be that
conclusion.
hard.
All right, this one. What do you think? Yes or no?
Yes. Yes.
This
No.
one is
No.
yes.
Eat it.
Oh wait, is this because
Okay,
all
if
all
these
alternate
two-
interior angles?
Yes, if these two alternate interior angles are congruent, which lines are parallel? The top and the bottom or the
Another
sides?
Parallel.
These have to be parallel. So some
So they're parallel and congruent.
there's a marking. Do you see the little arcs? This tells us that with the converse of alternate interior angles theorem, that these two lines have to be parallel.
Well, also you could just make it like two triangles and then all the sides would be congruent.
Yeah, but we want to just have that one theorem. So it's one pair of sides. This one's a little bit longer. Are parallel and congruent implies we have a parallelogram. This one already has the arrows included. If they didn't, you could assume that they're parallel. But is this enough information? The side, notice the side that was marked congruent was the same one as the side that was parallel? So what do you think?
Yeah. What? You're wrong. Wrong. I'm so confused.
Okay, I can draw the same thing. What if I drew this? Remember what I just told you about an isosceles trapezoid?
Well, that's one pair. Yeah. So it's.
So if I have, these are parallel, but the other sides are congruent, does that necessarily make it a parallelogram? No. Remember when we did counterexample? This would, saying isosceles trapezoid would be a counterexample that it wouldn't be a parallelogram. So this one's no.
What if all sides are congruent?
Well, then that would be true, because if opposite sides are congruent, that tells us we have a parallelogram.
But all opposite sides.
All opposite sides, that's the key. Reason we don't have one.
Oh, well, parallel lines congruent
What?
are what?
In a parallelogram, both pair of sides have to be congruent.
Parallel.
And
was there a
parallel.
reason for the bottom?
No, since it was, no, there's no reason. I mean, if you want to say not enough information, but okay, so find x and y so that the quadrilateral is a parallelogram. Right, so we're going to make 6x minus 12 equal to 2x plus 36. And we'll also make 6y minus 42 equal to 4y. You guys can solve that.
So is this the concept that's gonna be on the quiz?
This stuff will be on the quiz
When's the quiz?
Thursday. But notice these properties are the same properties that we did in the last class. They're just switched, converse.
Are we gonna have to use proofs on the quiz?
You will see soon enough the practice quiz.
Yes.
You can wait.
I got 12 and 21.
12 and 21. Same? We got 2 confirmed. 12 and 21. Good? Do we need to see the work for that, or everything checks? All right, how about B?
And she said like 7x equals 56.
All right, so yeah, opposite angles have to be congruent, so 7x has to be equal to 56, and 5y minus 26 has to be equal to 4y plus 4. That's an easy one. You can do that without
I
any.
got y equals 30.
8 and 30?
Yep.
Looks good. Okay. Good. Okay, so we want to determine on a coordinate plane, if you have these vertices, how do we know if we have a parallelogram? And we're using slope formula. What do we know about opposite sides? They have to be parallel. So what do we want here? We want to see if opposite sides have the same slope, right?
How do you know which sides are opposite?
Well, we're going to graph it. So let's see. B is at 0, 0. C is at 4, 1. D is at 6, 5. And E is at 2, 4.
Why would they start at X?
Does it matter? It doesn't matter. Okay. So what side should we do first?
How do you know how to label it?
What do you mean?
How do you know
The
how to
letter
label
in front? 0, 0 is B.
it? Oh.
I'm just labeling these. You know. Okay, now I could either do slope formula, which is y2 minus y1 over x2 minus x1. But since we have the graph, we can also just count rise over run. Easy, right? Let's do, what am I going to do? BC first. So if I'm going from B to C, so again, you could just do 1 minus 0 over 4 minus 0, or you could just look, oh, I have to go up 1 over 1, 2, 3, 4. So what's the slope for BC?
4.
1 over 4.
Oh.
1 over 4?
Rise. Whoa.
Okay, let's check DE, because it's going to be, we want to see if it's the same. Is it also 1/4 slope?
Yeah.
Up 1 over 1, 2, 3, 4? Yeah.
So that's all we need?
Well, we need both.
Oh. Why?
Okay, so those are parallel.
Can it be that only one set of sides are...
Okay, remember my counterexample of a trapezoid. Just because one pair of parallel sides doesn't mean the other two are going to be parallel. So let's check BE. What's the slope for BE? We can go up 1, 2, 3, 4 over 2. So 4 over 2 will give us a slope of 2. And we want to see if it matches with CD. Does CD also have a slope of 2? 1, 2, 3, 4 over 2. Yep. Okay. So, yes. It's a parallelogram. Good. All right, one more. Last one. See, we wasted all that time in the beginning. We could have had time for homework. Okay, let's graph it. -4, -3. So here's E. 4, -1. There's F. 2, 3. There's G. -6, 2.
He draws such straight lines.
Midpoint formula. How would I use midpoint formula to see if it's a parallelogram? What do we know about the diagonals? The diagonals have to bisect each other. So if the midpoint of the diagonals, are the same, then you have a parallelogram. Yes. Yeah. Okay, so do you remember the midpoint formula? x1 plus x2 over 2, comma, y1 plus y2 over 2. This one's kind of easier because you only have to do it twice. Rather than slope formula, you have to do it all 4 times. Let's look at HF, and then we'll do EG. Okay, so H and F. H and F. So 4 plus -6 over 2. Question? 4 plus -6 over 2, and then -1 plus 2 over 2. So that's going to be -1 comma 1/2. Am I going too quickly? A little bit. What's the midpoint of EG?
Why is it 1/2?
What's -1 plus 2 is? 1 divided by 2 is 1/2. Yeah. Okay, now let's look at E and G. So -4 plus 2 over 2. And -3 plus 3. Well, the first coordinate ends up being the same, but the second one is 0. If these two were the same, we would have a parallelogram. But since they're different, no, it's not. Yay. Of course it's that.